We're going to continue our lesson today from where we left off last time. We were talking about graphing linear inequalities on a number line, and now we're going to look at how to graph linear inequalities in a plane. Very much like graphing linear equations, and you can see the setup is very similar to our previous video. But in this case, we've got an inequality instead of an equation, and we handle that slightly different. We already know from the previous lesson that when we divide or multiply by a negative, we need to flip the inequality. But how do we indicate that it's not everything along that line, or a solution set when we have two equations is that point of intersection? But how do we show a range of solutions on a graph? So let's take a look at an example here. So we're going to use the inequality 2x minus 3y is less than or equal to 6. Okay, so if we look at this, y is not isolated. So I'm going to follow this path here and rewrite the inequality. And there's a reminder even here in our notes. Be sure to flip the inequality if you multiply or divide by a negative. Well, let's see how we're going to rearrange this to isolate y. So we've got 2x, I'm just going to rewrite it, 3y, because it's going to disappear on our screen. There we go. And we can see, we can create a zero pair here by subtracting 2x from both sides. We'll have negative 3y is less than or equal to negative 2x plus 6. Remove the negative 3. How do I get rid of it from that side? I'm going to divide because that's multiply. So divide by a negative 3 here. Whatever I do to one side, I have to do to the entire other side. So that's a 1y. We just say y. It's less than or equal to, and the negatives here will cancel out, so that's 2 over 3x plus and a minus, or positive and negative, so that would be minus 2. Now, I did divide through by a negative 3, so one thing that is missing is flipping the inequality sign. So let's remove that and rewrite it in this way. So how do I graph this? Well, you would graph this the same way you would graph this if there was an equal sign. The properties are still the same. When you have y equals mx plus b, you can see that your y-intercept is still negative 2. Your slope is still 2/3, right? You can see where that is from the m. But I have an equal sign here, which I shouldn't, right? So to graph this, we can take out our graphing calculators and put in under y equals 2 over 3x subtract 2. Now remember, the subtract is different than the negative, right? Your calculator understands that different. Now let's say we made a mistake, right? You can always go back and change that either using the insert or the delete or the clear if you want to wipe the whole thing clear. So there we go. That's our graph. We can go in and hit zoom 6 again. And you can see that graph being drawn right there. Okay. Now, when we look at our notes, it says graph dashed or solid. What does that mean? Well, the same way in our previous lesson, we had that a less than or greater than sign had an open dot, or a less than or equal to, greater than or equal to, had a filled in dot. The same thing applies for drawing our line here. So if we go down here, sorry, that's the next part. So shade or solid. So let's write in our notes up here. So if I have less than or greater than, that would be a dashed line. If I have less than or equal to, greater than or equal to, that would be a solid line on my graph. Okay, so let's draw our line in there. Okay, I'm just going to change the color on that if I can. So it's a little bit easier to see. And that didn't work, so we'll just leave it. Okay, so now that we have that, we still have to go in and label our key points. So if I go second trace, value, 0, enter. That gives me my y-intercept is at -2. -2. And then here for my x-intercept, second trace 0. And I'm going to go left bound and right bound. Yes, enter again. So that's at 3. Okay. And you kind of feel like you're done, right? But you're not. So the next thing it's asking us to do is shade or stipple above or below. So what exactly does that mean? Well, the shade or stipple refers to whether or not you have discrete data or continuous data. Okay? Now, discrete data, that means very specific values. Okay? When you're just given an inequality, we're assuming it's continuous. And if it's continuous, then we shade. When it's discrete, then we stipple. And we'll look at some more examples where you're going to have to stipple. But when you're just given an inequality like you see here, we're going to shade. But where do I shade? Do I shade above or do I shade below? Well, greater than or equal to means shade above. Even if it's just greater than, shade above. So if we have greater than or greater than or equal to, you shade above. If you have less than, or if you have less than or equal to, then we'll shade below. And that only works, well, that always works for lines except for a vertical line. So you can see if we had a graph here, and then we had a vertical line sitting here, for example, well, I can't shade above or below that line. So if it was greater than or equal to, I would shade to the right. If it was less than or equal to, I would shade or stipple to the left. Okay, and you would think of it as a number line, using your graph as your Cartesian plane as a number line there along the bottom. So you can see that it'll work in all scenarios except for vertical lines. Every other line will have an above or below in it. Okay. So if we even want to draw some examples here, so here if you had a line, let's say the line was going like this, just a quick sketch, shade above would look something like this. Shade below, if we had that same line, you'd be shading below. You can always test a point, right? Test a point in there, like if I check the origin and put it in, plug it into my inequality, it should either be valid or invalid depending on if you shaded in the right spot. We can look at that in this example up here. If you want to include the vertical line example, if it was a line here, shade above would look like that. That same vertical line, shade below would look like that. Okay, so if we look at our question here, we've got a greater than or equal to. So in this case, we will be shading. I'm going to change colors here. We will be shading above. Okay. Now, you can do this with your graphing calculator. Sometimes it ends up being a bit of a mess when you get lots of lines on there, but it's still nice to see and know that your calculator is capable of doing that. So if you go into y equals, and if you cursor over past the equal sign, you can see it's blinking on that. I know that I want to shade above, so if I hit enter, you can see that that's going to actually change. So there we go, shade above, and if you hit trace, you should see that shade above actually show up on your calculator. So that's nice that we can see that our calculator can do that as well. Now I was saying before that we could test a point. So if you ever wanted to check to make sure you did this right, so if I choose the origin here as a point, okay, and we can test that. That's just a side note. Let's test 0, 0. So instead of y, I put in 0, greater than or equal to 2 over 3 times 0, subtract 2. Well, 2 over 3 times 0 is 0, so I'd end up with 0 is greater than or equal to negative 2. Is 0 greater than or equal to negative 2? Yes, it is, and that's where I shaded. So I shaded in the right spot. If I didn't shade in the right spot, that would be invalid. So what this is showing us on this graph is this here is my solution set. Okay, that is the solution. Everything in that shaded region, including the line, because the line is a solid line. If this was just a greater than, not a greater than or equal to, then we would have a dashed line sitting there instead, and it would be everything above the line, not including the points along the line. But because this is equal to, you could choose points any point along the line or any point anywhere above the line, and that would still be valid. So unlike before, where the solution was a single point or everything along the line, this is a range of solutions. Now, it'd be a really good idea to go ahead and look at the next couple of examples. And here's that, what I was telling you about the solution region. The part of the graph of a linear inequality that represents the solution set. The solution region includes points on its boundary if the inequality has possibility of equality. So why don't we try A here, just because this is one that doesn't have, well, this is quite similar to the example we just did. So let's try, you guys can try A and B. And why don't I do C here? Okay, so starting from the beginning, I'm going to look at this and see that I have to rearrange my inequality. So I'm going to subtract 2x from both sides. I've got 3y is greater than negative 2x. You could put the plus 0, but that's not necessary. And then divide through by 3. So y is greater than negative 2/3 x. So pull up my graphing calculator. I'm going to clear this out. And write negative 2/3 x. Zoom 6. There I've got my line. And it looks like it's going through the origin, which makes sense. Let's double check. Value 0, enter, and that's at 0, 0. So x-intercept, y-intercept. Very nice. And I was about to graph this, but I got to look, is this a line that's dashed or is it a solid line? And because it's greater than, but not greater than or equal to, we can say that this line is going to be dashed. I could also see, because it's greater than, we're going to shade above. I don't have to worry about the stippling because it's not an example that would be discrete. So take out your straight edge and we can draw this dashed line. Now, on the surface here, I don't have a way to do that, so I'm going to freehand it as best I can, but just because the straight edge slides on here. But you're going to want to use a straight edge when you're using paper and draw this line through. That's not going through the origin. There we go. And I'm still going to put arrows on the end of it as if it was a solid line. So you can see because this inequality is greater than, we've got a dashed line, and I'm going to still shade above the same way I was shading above before. Okay, I'm going to label my x-axis and my y-axis, and there's my line, and it's going through the origin. You're going to put the 0 there. You don't need to. That's understood. That is the origin there. Okay, and again, if you want to pull out your calculator here, you can shade above and then hit trace, and you'll see that we shaded in the correct spot there. Okay, so go ahead and try those other examples, give them a go, and we'll go over them in class. Thanks for joining me today.